Hey guys, welcome back. Track out is done. I hope you guys had a great 2 weeks off. I know I was able to get out and enjoy the weather. It was fun. I actually celebrated my wedding anniversary. So I know Mueller's got her own wedding coming up pretty soon. And yeah, I celebrated 17 years with Mrs. Rotano. And did you guys ever see that movie Up? Up with Mr. Fredrickson, and they go on a tour, and I think they're in a hot air balloon. It's like they go to where do they go? Gravity Falls. So Mrs. Rotano got me this book, kind of from the movie, sharing our different adventures together. And this is pretty cool because it shares all 17 years of us together, from our time as young kids, in our 20s growing up, and going camping, and all the different adventures we've had, and vacations we've had, and our dogs and our kids coming into our lives. So this is really a really cool thing for Mrs. Rotano to give to me. We love pictures, we do, and it's good to think about all the memories we've shared. But the cool thing, and like the movie, is so many adventures, but there's a lot more to come. So that was pretty cool. I'll definitely have to share that with you when I see you again. So let's take a look at our lesson. Our lesson today. We're going to be adding, subtracting fractions, kind of like what we did before track out. But today we're going to be doing it representing in a picture, drawing a picture to represent that equation, and also to do the equation to match that picture. So yeah, we're going to use a visual model and the equation. So my example problem is Bryson. He was making trail mix with a recipe that called for 2 3/4 cups of pretzels and 3 3/4 cups of M&Ms. How many total cups of ingredients will Bryson use? All right, let's check them out. Let's see if we can help out Bryson. So it looks like we're going to combine these ingredients together. So we do have an addition equation. It said we have 2 3/4 cups of pretzels, and we have 3 3/4 cups of M&Ms. We want to know how many total ingredients will Bryson use. Pretzels, M&Ms, granola, raisins, goldfish. There's some good ingredients for trail mix. I think so. Okay, so to represent it in a visual model or a picture, let's represent our pretzels. I'm just going to represent that as a P for 2 3/4. So if I know it's 2 3/4 cups of pretzels. So to represent a cup, I'm just going to use a rectangle. So 1 cup would be a rectangle. My denominator says to break it up into 4 equal parts, or fourths. So there is 1 cup, and I'll shade that in to represent 1 cup, or 4/4. But I have 2 cups. So I'm going to represent another cup, also broken up into fourths, to represent my whole number 2. 4/4 plus 4/4 again, we're up to 8/4 so far. Then I have 3/4 left over. So I have my 2 full cups and then 3/4. So I have to bring another whole cup, or in this example, another whole rectangle bar, but I'm only shading 3/4. So I have 2 whole and 3/4 representing 4 of my pretzels. Now let's go over to our M&Ms. I don't know about you, but I like M&Ms in my trail mix. All right, so we have 3 whole cups broken up into fourths. So here's 4/4, 4/4 or 1 whole cup. I have another one, which is another 4/4. Or 2 whole cup, 4/4 and 4/4, we're up to 8/4. And then we're going to represent 3 whole cups. So we're going to have to represent another 4/4 for 3 whole. So 4/4 plus 3/4 is 8/4, and 8/4 plus another 4/4, we're at 12/4. But we still have a fraction. We have our 3/4 left over. So we're going to represent another cup, break it into fourths, and we're going to shade in 3/4. So my M&Ms, I have 3 whole, and 3/4. All right, now we're just gonna put them together and add. Now the easiest way for us to do that with a picture is just go ahead and add up all the whole cups. So we have 1, 2 from our pretzels, 3, 4, 5 from our M&Ms. Together we have 5 whole cups. And then it looks like we have, from our pretzels, we have 3/4. And from our M&Ms, we also have 3/4. Well, that's easy, guys. We know 3/4 plus 3/4. We can do that. We know the answer is going to be 6/4. So right now we're looking at an answer of 5 6/4. Now hold on. We can't give the answer as an improper fraction. If you guys remember from before track out, an improper fraction is when your numerator is larger than your denominator, and we don't want that, okay? Because we know if we have a numerator larger than a denominator, we actually have more than one whole, okay? So what we're gonna do is actually take away one whole. All right, ignore that 5 for a second and just focus on that fraction. If I have fourths, let's think to ourselves, what fraction is equal to one whole if my denominator is 4? Well, we know that 4/4 is equal to one whole. So I'm going to take that away from my 6/4, but I don't want to forget it. So I'm going to put a little box around it just to remind myself. And if I take away 4/4 from 6/4, we're left with 2/4. Now we did take it away from our 6/4, but we have to carry it to our whole number. So 5 plus 1 whole, or 4/4, is going to be equal to 6. So our answer is 6 2/4. Now we got to think to ourselves, 6 2/4, can we simplify that? Can we simplify 6 whole and 2/4? Well, factors of 2 and factors of 4, let me see, factors of 2, that's easy, it's 1 times 2. Factors of 4 would be 1 times 4, and 2 times 2. So the greatest common factor, the GCF of 2 and 4, well, that's easy, guys. We can see that's 2. And we can use the greatest common factor to simplify. All right. So 6 stays 6. That's our whole number. We only want to simplify that fraction. So 2/4 simplified would be 2 divided by 2, which is 1. 4 divided by our greatest common factor of 2, which is 2. So our answer is 6 1/2. All right. So that is that. Let's go ahead and back it up with our equation we practiced before track out. We practiced lining up our place values. We have 2 3/4 plus 3 3/4. We did this before. We just simply stack them up, line up our fractions and our whole numbers, and just do simple math. 3/4 plus 3/4 is 6/4. 2 plus 3 is 5. So again, we have 5 6/4, which we know we have to convert because we cannot have an improper fraction. We want it to be a proper fraction when our numerator is smaller than our denominator. We can't give this final answer as an improper fraction. So again, we're just going to simply take away one whole. 6/4 minus 4/4, we get 2/4. And we can't forget, when we take that 4/4 away, we got to put it somewhere. We're going to add it to our whole number. So 5 plus, well, really 1 whole is going to be 6. So we get 6 2/4, which we simplified it to 6 1/2. So how many cups of pretzels and M&Ms does Bryson have? He has 6 1/2 cups of ingredients. All right. So yesterday was Easter, and one of my favorite Easter candies are these Reese's peanut butter chocolate eggs. Oh, guys, these are the best. So I have to take this and have a snack. Might be a little challenge for you guys on your assignment today to see what Mr. Ratano had for snack, but all right, there's good. I hope you guys had a good Easter. Didn't eat too much candy. Maybe save some for today like me. All right, it's good. Okay. So my next one is a subtraction problem. So the problem says Mr. Rotano is planning a pizza party for his awesome fourth graders. You guys are awesome. The girls ate 3 5/8 pizzas, and the boys ate 2 7/8 of pizzas. That's bragging rights right there, guys. We want to know how much more did the girls eat than the boys. So the girls ate more than the boys. So since it says how much more, it looks like we're subtracting here, guys. And the girls ate 3 5/8, and the boys ate 2 7/8. And yeah, we're gonna go ahead and subtract to see what that is. Okay, first things first, visual model, guys. We have the girls, put in my little G for my ladies, and they ate 3 5/8 pizzas. So I'm gonna use circle for this visual model for my picture. My denominator is 8, so I'm gonna break my whole pizza up into 8 slices, like so. And I'll do little marks to represent each pizza slice. Kind of looks like a basketball. Okay, so that's one whole pizza. The girls ate more than that. They ate 2 whole pizzas. 3/8, 4/8, 5/8, 6/8, 7/8, another 8/8. So 8/8 is 16/8, and they ate 3 whole pizzas. So break that up into 8s again, because our denominator tells us how many equal parts. So 3/8 is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So I have 8, 16, 24/8. Cool. But we have 3 whole pizzas. We also have 5/8 of another pizza. So let's go ahead and draw our last pizza in here. But the girls didn't eat all of that. They only ate 5 out of the 8 slices. So let's shade in 3/8, 4/8, 5/8. Okay. So now, a little different than before. We drew a picture for both of these mixed numbers. You don't have to do that with subtraction. All you have to do is draw your first larger number, 3 5/8, and we're simply going to take away 2 7/8. So let's do that. Take away 2 7/8. Easiest way to do that, like with our visual model, is to go to our whole number, 2. All right, so let's take away this whole pizza and that whole pizza. So now we're down to 1 5/8. So we took away our 2. Now we want to take away 7/8. Okay, I'm going to go to this pizza, which is whole, and I'm going to just cross out 7/8. I know the whole pizza is 8/8, so I'm just going to cross out 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. But I'm left with 1/8 left. And you know what? I'm just going to simply move this to my next pizza. That 1/8 I have left, I'm just going to add that to this pizza. And that's my answer right there. I subtracted 2 whole and 7/8, and then combined what I had left. And it looks like we have 1/8, 2/8, 3/8, 4/8, 5/8. Looks like we have 6/8 of a pizza left. So kudos to my girls. You guys can eat some pizza. Can we simplify? Can we simplify 6/8? I don't know. Greatest common factor between 6 and 8. Let me see. 6 is 1 times 6, 2 times 3. Factors of 8 are 1 times 8, 2 times 4. So the greatest common factor of both 6 and 8, looks to me like 2 is the winner here. So we can simplify. Indeed. So 6/8 simplifies to, let me see, 6 divided by 2 is 3. 8 divided by 2 is 4. So our answer is 3/4. The girls ate 3/4 more pizza. Now, does our equation match our drawing? Let's check this one out, guys. Same as before, we're going to take our larger number. We're going to put it on top, 3 5/8. Our smaller number goes on the bottom, lining up our fraction and their whole number. And this time we're going to subtract. So we want to start with our fractions. And now if you guys remember, I'm trying to take away 7/8 from 5/8. I can't do that. Can't do it, don't have enough, so I need to borrow. In this problem, I cannot do 5/8 minus 7/8. I need to borrow from my whole number. So I'm gonna do that. I'm gonna cross out the 3. I'm gonna take 1 away. When I take 1 away, we are left with 2 whole. Now that 1 comes over in the form of a fraction. All right, well, let's think to ourselves, what fraction is equal to 1 whole? In this example, our denominator is 8, so the fraction equal to 1 whole would be 8/8. So all we simply did was just borrow. That's all we did so far. We didn't subtract anything yet. Now we have 8/8 we brought over, but we already had 5/8 there before. We have to combine them together. So 8/8 and 5/8 we know is 13/8. Okay, so all we did was just combine those fractions, but we can't forget about our whole number. So we have 2 and 13/8. Remember guys, we didn't subtract anything yet. All we did was just borrow. Now we can slide over our 2 and 7/8, 2 and 7/8, and we could do some subtraction here. 13/8 minus 6/8. 13 minus 7 is 6. You get 6. 6/8, and then 2 minus 2, of course, is 0. So again, we're looking at the answer of 6/8, which we simplified, and we know 6/8 is equal to 3/4. So again, guys, our equation backs up our drawing. Girls ate 3/4 more pizza. I miss you. I hope to see you soon, and until next time, don't forget what I had for my snack in my